Hi, in this video, I'll be going over the answers to the study guide for Newton's second law. Your test is expected for Thursday or Friday, depending on which period. Your worksheet may have slightly different numbers than the problems that I have up here. You can change the numbers on your worksheet so that they match, or you can do these problems on a separate sheet of paper. Number 1, we already went over, but we'll review it again. In this problem, there's a 15 kilogram box at rest on a table. How much force of gravity is acting on the box? I'm being asked to solve for a force of gravity, so I'll need to use the equation for calculating the force, where m stands for mass, which is given as 15, and g is a number that means gravitational field strength, and assuming it's happening on Earth, I use the number 10. Multiplying mass times 10 will give me 150 newtons, and that's the final answer for how much force of gravity is acting on the box. In part B, I'm asked for how much is acting on the box. The normal force will be the same amount as the force of gravity, since the forces are balanced. So the answer here is also 150 newtons. For an object that is constantly at rest, the acceleration will be 0. And that's because it has balanced forces and it has constant velocity. In number 2, a 65 kilogram person is riding an elevator downward. The force diagram is shown over here. How much weight does the person have on Earth? If this person has a mass of 65 kilograms, I can find their weight, which is a force of gravity, by multiplying 65 and 10, which represents the gravitational field strength of Earth. The final answer will be 650 newtons. I draw a circle around it to make my final answer obvious. In part B, we're asked to show how much normal force must be acting on the person in order to accelerate this much. So I'm being asked for a specific amount of force that's here on the force diagram. In order to do that, I need to set up Newton's second law. Now remember, Newton's second law, there's one equation that can be written in two different ways. There's the one in blue on the left and the one in green. They are the same equation, just written two different ways. This equation here is more useful when solving for force. If I'm trying to find acceleration, that's when I would use the green one. So, the left side of this equation represents sum of forces, or the total force. In this problem, there are two forces on the object, the normal force and the force of gravity, and they are going against each other. So to show the total force, I need to use the symbols for both Fn and Fg. And even though total force means I'm adding forces, in this case, I'll be subtracting them because they go against each other. If they were two forces going in the same direction, then I would be adding instead of subtracting. Newton's second law says that if I find the total force, it will equal the amount of mass times the acceleration. And in this problem, the mass that's given is 65. given right here. And the acceleration, it tells me, is 2 meters per second. This is acceleration right here. So on the right side of the equation, I can multiply, 65 times 2, and I can use my calculator to find that that equals 130 on that side. On the left side, Fn is what I'm trying to find out. But I know Fg is 650 from the first part. So to find the answer, I need to figure out what number that I plug in here for Fn when I subtract the 650 newtons of force of gravity will still cause this acceleration. I can add 650 to both sides, and I find that the final answer for the amount of normal force to cause that acceleration of 2 on the object is 780 newtons. And that's the final answer. Now, to summarize this process, I needed to first read the problem and annotate any given information to figure out what it is that I know and what it is that I need to find out. The only equation we'll be applying for these problems, well, there's two of them. One is the force of gravity equation, and the other one is Newton's second law, which I'm going to highlight in green. But it's up to me as the physicist to use my understanding of sum of forces, mass, and acceleration to figure out the missing information. So in this case, how much normal force. The left side of the equation represents total force. This is total force. And the right side is just mass times acceleration. In another problem, we'll see how you can use the other version to find acceleration. But it's the same quantities being represented, where this side is acceleration, and then on the other side, you have to put the total force on top and divide it by the mass. Now, on your own, look over problem number 3. Maybe it's unfinished on your paper. Maybe you've already solved for it. Remind yourself and summarize the process that you took to solve for number 3. Pause the video here to give time for solving number 3. Number 3. A 75 kilogram person, that's mass, is riding an elevator upwards and slowing down. The normal force on the person is 400. This information I can add to my diagram. I can say that the force upward is 400 newtons. How much Fg does this person have? The force of gravity on this person is their mass times 10, which is 750 newtons. Next, I'm asked to find the acceleration of the person. Before moving on, I can add the 750 to my diagram to help me visualize the total force on the object. There's only two forces, 400 going up, 750 going down. And for the next part, I'm asked to find the acceleration. To find the acceleration, I can use Newton's second law, except this version, where acceleration is on one side and net force divided by mass is on the other side. Remember, the symbol at the top represents total force or overall force. And there's two forces here, one going up, one going down. The amount going down will take away from the amount going up. So overall, how much force is acting on the object? If I write a process, I would show that the total forces that go on the top is Fn minus Fg, and that's all going to be divided by mass to find acceleration. So what I've done here is just substitute in for the net force this expression, which is specific to this snapshot. I can continue to show the process by plugging in numbers that I know for normal force and the force of gravity. I also know how much mass from the problem, 75 kilograms. And I know that's the mass because it's kilograms. To get my final answer for acceleration, I just need to do this carefully on my calculator. Make sure that you're doing the math for the top part before you divide by 75. Otherwise, you would get the wrong answer. So in my calculator, I subtract 750 from 400, and that gives me negative 350. And I want to be clear in my processing to show that I understand how to apply Newton's second law to any given situation. And just a reminder that you may have different numbers than what I have up here. When I find out the top part, it's negative 350, and that divided by the mass, which is 75, gives me a final answer that I'm going to round to about 4.7 meters per second squared. Now, it's an acceleration, so that's how I know that the final units should be meters per second squared. So let me summarize my steps. I first read and annotated the problem. And when I found out how much force of gravity there was, I added it to my diagram to help me visualize which forces are acting on the object, here and here. Then I chose Newton's second law to help me. And I plugged in for the force at the top, the two forces going against each other. And I plugged in for the mass. Then I used math to find the final answer, which is 4.7 meters per second squared. Now, please move on and try out number 4. Remember to read and annotate the problem first, then decide how you're going to use Newton's second law to help you find what it's asking for. Here's the answer for number 4. I start off by reading the problem, and it says there's a 45 kilogram box that's pulled across a frictionless surface and speeding up. The speeding up part tells me that the forces are unbalanced, so it has changing velocity. These letters help remind me how Newton's first law applies. If something's speeding up, then it's changing velocity, so unbalanced forces. Part A says there's 600 newtons of tension force. I could even add that to the diagram. There's 600 pulling to the right. What is the acceleration of the box? Since it's asking for acceleration, I can use this version of Newton's second law. I'm going to go a little faster now. There's only one force that goes on the top. So when I fill in and plug in numbers to the equation, I have 600 newtons at the top because there's only one force that's causing it to go sideways, and divide it by the mass. I can ignore the forces going up and down because the box isn't moving that way. The final answer is 13.3.